Hello everyone. In continuation with the last class, today I'll be discussing about the basic terms that are used in the microprocessor and the buses of the microprocessor. So to start with the basic terms, the first one is I'll be discussing about chip. What is chip? A chip or an integrated circuit is a small thin piece of silicon with the required circuits and transistors etched on it to perform a particular function. Simpler processors may consist of a few thousand transistors etched onto a silicon base just a few millimeters square. The next term is bit. A bit means a single binary digit. The bit is also the fundamental storage unit of computer memory. In binary form, a bit can have only two values, 0 or 1. The next term is word length. For users' convenience, input and output devices use decimal digits, alphabets, symbols, special characters, images, etc. They are all converted to binary codes or formats consisting of binary digits 0 and 1 internally for processing by the CPU. The number of bits that a digital computer can process in parallel at a time is called its word length. For example, 8-bit microprocessor can process 8 bits data at a time. 16-bit microprocessor can process 16 bits data at a time. In a similar way, 32-bit microprocessor can process 32 bits at a time, etc. A processor of longer word length is more powerful and can process data at faster speed as compared to shorter word length processor. The next term is word. Word is a number of bits grouped together for processing. In microprocessors, a word refers to the basic data size or bit size that can be processed by the arithmetic and logic unit of the processor. A 16-bit binary number is called a word in a 16-bit processor. The next term is memory word. The number of bits that can be stored in a register or memory element is called memory word. Mostly all memory units use 8 bits for their memory word. The next term is byte. An 8-bit word is referred to as byte. The next term is nibble. A 4-bit word is called as nibble. The next term is kilobyte. A collection of 1024 bytes is called a kilobyte, which is equal to 2 to the power 10 bytes. The next is megabyte. A collection of 1024 kilobytes is called a megabyte, which is equal to 2 to the power 20 bytes. So the next term is RAM or read-write memory. Random access memory or read-write memory is a type of semiconductor memory in which a particular memory location can be erased and written with new data at any time. These memory units are volatile, which means that the contents of the memory are erased when the power to the chip is disrupted. So basically, there are two types of RAM: static RAM, SRAM, and dynamic RAM, DRAM. SRAM retains the stored information. SRAM means static RAM retains the stored information as long as the power supply is on. But a DRAM loses its stored information in a few milliseconds even though its power supply is on. A DRAM stores information in the form of a charge on a capacitor which leaks away in a very short time. Therefore, its contents must be periodically, usually every 2 milliseconds, be refreshed by restoring the capacitor charge to its full value. It requires a refreshing and control circuitry. A DRAM needs only one transistor per memory cell, where a memory cell is an electronic circuitry which stores a binary bit 0 or 1. Moreover, DRAM consumes less power and is cheaper than SRAM. Whereas SRAM uses conventional flip-flop circuit consisting of two cross-coupled inverters to store binary bit 0 or 1. 6 transistors that make up a flip-flop are needed to form a memory cell of SRAM. It is faster than DRAM. There are additional transistors that are used to control read and write accesses of storage cells. Each SRAM can be used in 3 different states called read, write, and standby. The next term is ROM, that is read-only memory. ROM are memory devices whose contents are retained even after removing the power supply. The next term is bus. Bus is a group of wires or lines that carry similar information. The next term is system bus. The system bus is a group of wires or lines used for communication between the microprocessor and peripherals. The next term is firmware. Software written for a microprocessor application without provision for changes is called firmware. These are stored in the permanent storage or ROM of the computer system. The next term is input device. The device that are used for providing data and instructions to the microprocessor or microcomputer system are called input devices. Keyboard and mouse are the common input devices. The next term is output device. The devices that are used for transferring data out of the microprocessor or microcomputer system are called output devices. Display screen, printer, and other forms of display are the common output devices. And the last term that I'll be discussing is clock. The circuit in the computer that generates the sequence of evenly spaced pulses to synchronize the activities of the processor and its peripherals is called clock. The clock speed determines the speed of the operation of the computer. A computer with a high frequency clock works faster. Normally, the clock frequency is in the range of megahertz or gigahertz. So, I will also be discussing about the von Neumann and Harvard architecture. I hope most of the people know these terms. Still, I'll be discussing here. So basically, von Neumann architecture refers to the architecture in which the same memory is used for storing programs as well as data. Whereas Harvard architecture refers to the architecture in which programs and data are stored in two separate memory units. So these were the common terms that are generally used in the microprocessor and will be required for your futures. So the next topic that I'll be discussing here is buses. Various input and output devices and memory devices are connected to CPU by group of lines called buses that I've already discussed. So basically there are three types of buses: address bus, data bus, and control bus. So the address bus carries the address of a memory location or input-output device that the CPU wants to access. When an address is sent by the CPU, all devices connected to the CPU through the address bus receive this address, but only that device will respond which has also received chip-enabled signal from the CPU. Thus, address bus is an unidirectional bus. In case of address of a memory location, the output of program counter within the microprocessor is given to the memory. The internal decoder in the memory decodes the output of the program counter to locate a specific register in the memory. This means that the output of the program counter addresses a specific register in the memory. The width of the address is decided by the designed memory addressing capability of the CPU. That is, the width of the address bus will be equal to the width of the program counter. So here I have used a new term, program counter. Let me introduce you what is program counter. Program counter is one of the most important registers in the microprocessor. As we all know, program is a series of instructions stored in the memory. These instructions tell the microprocessor exactly how to solve a program. So the program counter gives the address of memory location from where the next instruction is to be fetched. So it stores the address of the next instruction. So coming to the buses, the next is data bus. The data bus is bidirectional. It is used to transfer data, example opcodes, operands, etc., between the processor, memory, and input-output devices. The data bus within the microprocessor is called internal data bus, whereas data bus outside the microprocessor is called external data bus. The width of the data bus is same as the word length of the CPU. Example, an 8-bit microprocessor has 8-bit data bus. Therefore, the size of the data bus decides the size of the operands and decides the maximum number of operations that microprocessor can perform. So the next is, and the last one is control bus. Control bus is used to carry necessary control signals between the CPU and memory and input-output devices. Example of control signals are, you will get to study the control signals like RD bar, WR bar, IO/M bar, etc. So I'm discussing few control signals. The microprocessor uses IO/M bar signal to indicate whether it will communicate with an input-output device or memory. If IO/M bar signal is high, CPU wants to communicate with an input-output device. If IO/M bar signal is low, the CPU wants to communicate with the memory. When the CPU sends a low RD bar signal, the activated devices understand the CPU wants to read information. When the CPU sends a low WR bar signal, the activated device understands the CPU will perform write operation. So up to this, I am ending this class. We'll continue further in the next class. Thank you.